Let's factorize x squared minus 9. This expression is in a special type of form known as the difference of two squares. Now what this means is that there's a special identity we can use to factorize this expression instantly. Now this is the expression, the identity. A squared minus b squared equals a plus b multiplied by a minus b. And the conditions that you need to use this identity is that both terms in the expression need to be perfect squares. So in this case, x squared is a perfect square and 9 is a perfect square. And then the second condition is that there must be a minus sign in between the two terms. And so, from here, if we find what the square root of x squared is, square root of x squared is just x, and then the square root of 9 is 3. We can rewrite this expression, x squared minus 9, as using the identity above, x plus 3 multiplied by x minus 3. And so we've used the first term in the expression, x squared, and square rooted it and put the x here and here at the beginning of the two brackets. And then our second term, this 9, we found the square root, and then we've got now plus 3 in the first bracket and minus 3 in the second bracket. And so that's the pattern that you follow whenever you see an expression in this form, as an easy way to factorize it. So now let's try some examples. Now for our first example, let's factorize x squared minus 25 using the identity for the difference of squares. So I'll rewrite the identity up here. A squared minus b squared equals a plus b multiplied by a minus b. And so, let's square root the first term in this expression here. The square root of x squared equals x, and the square root of 25 equals 5. So x becomes our term 1 and 5 becomes term 2. So now we can write the factorized form, that is x plus 5 multiplied by x minus 5. For the next example, we have x squared minus 36. So once again, the square root of x squared is x, and the square root of 36 is 6. And so now we can write the factorized form as x plus 6 multiplied by x minus 6. And this is the factorized form of that expression. And now for this last example, we know that the square root of x squared is x, and the square root of 16 is 4. And so using those two terms, the factorized form of x squared minus 16 is x plus 4 multiplied by x minus 4. And so this is basically the pattern that you're observing, and you follow the same method each time you do this sort of factorization, all going back to this identity in the top left corner. Now this is a bit of a trickier example. Let's factorize 4x squared minus 25. And the only difference is that in this case, we have a coefficient that isn't 1 next to the first x squared. But we can still use the identity because 4x squared is still a perfect square. So if we write the square root of 4x squared, the square root of 4 is 2, and the square root of x squared is just x. So the square root of 4x squared is 2x. And then the square root of 25 equals 5. And so for this expression, 2x is our term 1, and 5 is our term 2. So now we can write the factorized form, 4x squared minus 25 equals 2x plus 5 multiplied by 2x minus 5. And this is the factorized form using the difference of squares. Our final example, I want you to factorize 9x squared minus 16y squared. And so just like we've done before, we want to find the square root of the first term and the square root of the second term and use that in our factorization. And so the square root of 9x squared is 3x, and the square root of 16y squared is 4y. And so 3x is our term 1, and 4y is our term 2. So we can write the factorized form, 9x squared minus 16y squared equals 3x plus 4y multiplied by 3x minus 4y. And so that covers the main idea of the difference of squares. And to summarize it all, anytime you see an expression in the form of a squared minus b squared, you can factorize it using the identity a minus b times a plus b.